million people. Just offshore, one of the largest earthquake-producing faults on the planet. Scientists have been studying it for decades, and now it's a powder keg ready to blow. First, it unleashes the largest quake to hit the region in 40 years. Next, the deadliest natural disaster in history claims over 250,000 lives.
It was a surprise that it was so devastating. It caught us off guard.
It went from a perfect day in paradise to this horrific day in a matter of seconds.
Oh my God!
Scientists are baffled by a series of bizarre phenomena as freak waves destroy entire communities.
The mega tsunami of 2004 is the greatest mystery we have yet to unravel.
Now, using cutting-edge scientific analysis, they shed new light on what really happened and reveal why tsunamis are an even greater threat than we ever imagined. Disasters don't just happen. They're triggered by a chain of critical events. Unravel the clues and count down those final seconds from disaster. The Indian Ocean, the third largest in the world. A huge trench runs along its eastern boundary at the edge of a giant fault line called the Sunda Megathrust. Here, two of the world's massive tectonic plates collide. Geologist Carrie C. has studied the fault for a decade.
The plate's the biggest moving objects on the planet. The Indian plate is diving down beneath the Asian plate, and the overriding plate gets dragged down with it.
This collision zone is a breeding ground for earthquakes. The northern end of the fault has seen almost no major activity for at least 500 years. But the southern end is a different story. Here, a major earthquake strikes about once every 2 centuries.
The last one was in 1833, so almost 200 years ago. We were getting a little nervous that sometime in the next minute to next 30 years, that part of the megathrust might break again.
The megathrust is well known to geologists. But most people who live, work, and play in the area were completely unaware of the danger. That is, until December 26th, 2004. The Thai island of Koh Phi Phi. More than 150,000 tourists flock here every year to experience its lush scenery and magnificent beaches. December 25th, 2004. The Moore family from California are having the vacation of a lifetime.
Hi, girls. Hi, Danielle.
It was our first time in Asia. Phi Phi Island was like no other place I'd ever been to before. Pure paradise.
Ken films his wife Gayleen and their daughters Kendra and Danielle as they enjoy a tropical Christmas.
Merry Christmas.
With my kids being 6 and 8. The best thing about Christmas was they had a big party. Our children were having a wonderful time.
Good job. And there's our hotel.
But Thailand is just one of more than 20 countries that surround the Indian Ocean. About 300 miles away lies the politically troubled island of Sumatra, and on its west coast, the community of Lucknow. Despite more than 2 decades of civil unrest here, the people of Lucknow maintain an easygoing rhythm of life. About 15,000 people live here, crowded along a narrow strip of land between hills and the ocean. December 26th, 2004. 7:57 a.m. Ibu Nurlerli hangs up the family washing. Inside, 3 of her children are eating breakfast and watching TV.
We live near the ocean, and this morning there is nothing unusual. No wind, clear blue sky.
The youngest of Ibu's children is 9-year-old Ishut, a bright, thoughtful girl. She likes to help her mother with the chores. Ishut has a 16-year-old brother and a 17-year-old sister who's been blind since birth. 7:59 a.m. Deep beneath the ocean, the earth begins to shake. The violent tremors last for more than 8 minutes. Ibu and her children are terrified.
We stay in front of the house, just praying while sitting in front of our house.
At 8:15 a.m. An enormous wave flies toward the Sumatran coastline. 8:16 a.m. The quake is over, but across the region, shock and devastation remain. 28-year-old street trader Samsul Kamal surveys the damage. He looks towards the ocean and sees a huge stretch of exposed seabed, where the ocean has somehow drained away. Immediately, he senses danger.
I know if the sea goes out that far, it will come back again.
Then he sees it. A massive wall of water hurtling towards the coastline. Within seconds, Lakna is under siege, pounded by the enormous wave. A second wave thunders towards Ibu and her family. This one's much higher and towers over the trees.
We see the water. It is as high as a mountain.
Ibu desperately tries to hold on to her little girl, Ishut, but the violent waters are too strong. Meanwhile, on a nearby hilltop, Samsul watches as a third, even larger wave approaches. He's more than 100 feet above sea level, and still the wave nearly kills him.
The third wave went right over my head.
8 miles north lies the city of Banda Aceh, home to 300,000 people. 8:40 a.m. An amateur cameraman films the aftermath of the quake. He's in the city center, over 2 miles from the coast. And he captures this footage as seawater pours into city streets. Suddenly, the flow accelerates. Within seconds, it transforms into a deadly torrent of water and debris. After wreaking havoc in Sumatra, the tsunami continues its journey eastwards. On the resort island of Koh Phi, the Moore family enjoys the last moments of a memorable vacation.
Being that it was Christmas the night before, we were up late, and we just took a leisurely breakfast. And I remember thinking, oh, about another half an hour, we need to check out.
In their third-floor hotel room, Gayleen and her daughters, Kendra and Danielle, are just about to finish their packing.
My wife all of a sudden said, honey, look, grab your camera.
The first deadly wave has just slammed into the pool area.
At first, I I just thought it was just a little tidal surge until I looked farther out into the bay and realized there was a 20-foot wave coming at the beach.
Oh my God, look at the wave coming! Clear out, people!
I surfed, so I knew this wave had the potential to knock the hotel down.
Look out! Get in the room, get in the room.
We're trying to get the kids back away from the window in case the wave came through the window.
There's no time and no way to escape.
I was beginning to lose it, and my wife said, no, we can't do that. We've got to be strong for the kids.
People near the eastern Indian Ocean are fighting for their lives. Meanwhile, 1,200 miles to the west in Sri Lanka, the Squire family is enjoying what seems like a perfect day. They're vacationing on the gorgeous beaches of Arugam Bay.
We knew it was one of the last family holidays that we'd probably be having as the children were getting bigger.
Louise and Phil have 3 children. 16-year-old Will, Laura, who's 18, and their eldest, Emma. Today is Emma's 20th birthday. Louise and Philip plan to meet Emma at the beachfront dining area. But first, Emma wants to freshen up. While waiting for her daughter, Louise notices something odd. Water seeping into the hut.
The floor of the restaurant begins to flood with water.
Then she spots a wide brown surge of water speeding towards her.
Something tells me this is incredibly life-threatening.
Louise's first thought, Emma. She'll have no clue that a killer wave is about to strike. There are just seconds to act. Seconds which could spell the difference between life and death. On the Asian island of Sri Lanka, Louise Squire spots an enormous wave. A killer tsunami is just seconds away. Her daughter Emma is unaware of the danger. Tons of water explode into the room. Within seconds, Emma is trapped and running out of time. Powerful currents tear the resort to pieces, and Louise is swept away.
The next thing I remember, I'm just under a huge amount of water. And I'm thinking, this would be so easy to die in.
Finally, she drags herself to safety.
I remember thinking, where are my children? But knowing there was nothing I could do.
Over the next 2 hours, a series of waves swamp Arugam Bay. Eventually, the water recedes, and a living nightmare is revealed.
I see a completely devastated area.
Desperate to find her family, Louise makes her way to the highest point of the island. It's her last hope of finding them alive. But there's no sign of her children or husband. Her family, her whole world is gone.
I start planning my own exit from the world.
But then, familiar voices.
Phil comes through the garden, followed by Emma, Laura, and Will. And it was just unbelievable. And we just hugged each other. It was amazing. She just kept on repeating, I thought I'd lost you, I thought I'd lost you. We were all in tears. We couldn't believe our luck, how all 5 of us could have survived.
But the tsunami continues on its deadly path, finally reaching the coast of Somalia in Africa. By now, its waves are diminished, having traveled over 3,100 miles. And yet, even here, it claims 289 lives. All across the Indian Ocean, incredible events have been captured on video. In Thailand, tourists film an exposed seabed where the water drained from the beach. Minutes later, it's pounded by a vertical wall of water. 1,900 miles to the southwest, the Maldives. These low-lying islands are all but submerged. To the north, in Sri Lanka, a shopkeeper records this footage of schoolgirls trapped in what was a bus station. Back on Koh Phi Phi, the Moore family has survived the tsunami. But as the flooding subsides, they find that thousands of others were not so lucky.
The people in that bay were gone. We'd been out there snorkeling and swimming the day before, and this wave just came and picked everyone up and just washed them away. There was people with horrific injuries, I mean, broken arms and legs twisted and lacerations. Sheets covered people that were dead.
On Sumatra, the coastline is now unrecognizable. Ibu Nurlerli desperately searches for her children.
After the water receded, I was confused and frightened. There were so many dead bodies. Not only people from this village, but people from other places too.
Finally, Ibu finds her blind teenage daughter, then her son. Together, they look for 9-year-old Ishut, sifting through debris and corpses. But it's a race against time. With each passing minute, their chances of finding Ishut alive are dwindling. By some miracle, Ibu Nurlerli has survived a series of killer waves, but her daughter Ishut is nowhere to be found.
We look for Ishut everywhere.
After hours of fruitless searching, the awful truth is inescapable.
I couldn't find my little one. I haven't seen Ishut to this day.
Like so many youngsters, Ishut wasn't strong enough to survive the water. At least a third of the tsunami's victims are children. This is the most devastating tsunami in recorded history. Entire communities are erased. Sumatra alone loses around 170,000 people. In total, more than 270,000 are killed. The true death toll will never be known. But what caused the tragedy? What kind of tsunami can create super high waves, retreating oceans, and devastating debris flows? And most important of all, is there anything we can learn to prevent such a catastrophe from happening again? To understand a disaster this complex, you need experts from many different disciplines. So a team of world-class specialists come together to investigate. But for earthquake expert Carrie C., their mission raises conflicting emotions.
It's quite a schizophrenic experience. You have not only your scientific exhilaration, but you also are looking at something that's powerful enough to do a lot of damage to people.
Professor Kostas Sinalakis is head of the Tsunami Research Center in California. He's investigated tsunamis for over 25 years, analyzing freak waves in 10 different countries.
Our work is very much like the FBI profiling a serial killer. We have to very, very carefully look at the clues. Then we can maybe point our finger and say, this is where the killer came from, and this is what he can do again.
Sinalakis is an expert in modeling tsunamis. He tries to predict what would happen to low-lying coastal communities like Los Angeles if they were hit by super destructive waves. Then, based on his findings, he suggests the safest places to build public buildings, like hospitals. The Asian tsunami perfectly illustrates the need for this kind of research.
Tsunamis, they're inevitable. It's just a question of time.
George Plafker is a pioneer of tsunami science and has been studying them since the 1960s. Even he is stunned by the images coming in from all around the Indian Ocean.
What was really surprising was the size of the tsunami and how destructive and deadly it was.
For all the experts, there are some especially troubling aspects of the disaster. The first is the unprecedented size and savagery of the waves. Their pure destructive power causes massive damage in places like Banda Aceh. The extraordinary range of the tsunami is also puzzling. It causes chaos from Thailand to Africa, across more than 3,700 miles of ocean. That's about 1/7 of the Earth's circumference. It's almost unthinkable.
What happened was beyond any scenario we had ever seen or imagined ever before.
This is the CBS Evening News.
As the disaster unfolds, the media coverage begins. They report that the tsunami was caused by an earthquake,
followed by tidal waves.
the same earthquake that rocked Sumatra just minutes before the killer waves arrived. And the experts agree. But as early seismic data comes in, some things still aren't adding up. For instance, initial reports indicate that the earthquake measures 8 on the Richter scale.
Now, to put this in perspective, we see a magnitude 8 earthquake somewhere around the world, maybe once every 2 years.
A relatively common magnitude 8 quake isn't powerful enough to produce this kind of devastation. As monitoring stations revise and analyze their data, the estimate steadily increases. By afternoon, a station in Colorado puts the quake at 8.5.
If that's the size, it would be the biggest earthquake in more than a decade.
By day's end, data from around the world confirms that the quake lasted an unprecedented 8 minutes. And it released so much energy that it's actually off the Richter scale.
By that point, we knew it was the biggest earthquake in 40 years.
The seismic data throws up another surprise. The origin of the quake was actually 19 miles below the surface and 93 miles from Sumatra, which means it originated in the northern section of the Sunda megathrust, the part long thought to be practically dormant. Seismologists estimate that the megathrust ruptured along 250 miles of the fault, causing a massive section of ocean floor to rise in a matter of seconds. Sinulakis is all too aware of what could have happened next. As the seafloor moves up, it lifts with it a column of water, displacing billions of tons of liquid, causing a wall of water to move away on either side. To prove the scenario, Sinulakis feeds the data into the most powerful tool he has, specialized tsunami prediction software. And the results of the simulation? Puzzling, to say the least. The software predicts that the biggest waves from a 250-mile rupture wouldn't even hit Sri Lanka. But in reality, this was one of the most devastated coastlines.
It just doesn't make sense. The damage in Sri Lanka is a huge clue. For the tsunami to have hit Sri Lanka, the earthquake fault zone has to be way longer.
So Sinulakis decides to revisit the seismic data. He knows from experience that seismic measurements recorded during a large quake don't always accurately reveal the true length of the earthquake zone. The sheer intensity of the main event can mask smaller movements further out along the fault. Often, the best way to get at the truth is by examining the aftershocks. These smaller tremors, caused as the fault settles down, can be pinpointed with greater accuracy. As Sinulakis scans the data, he notices a flurry of tectonic activity far north of the epicenter. It's a critical observation. If this activity marks the northern limit of the rupture, that means the rupture is a staggering 1,000 miles long, 4 times longer than originally thought. A rupture on this scale would be unparalleled and powerful enough to cause the killer tsunami. But the aftershock evidence is circumstantial. Sinulakis needs some real proof. If this fault has ruptured over such a long distance, there should be evidence somewhere along its length. Sinulakis knows that Carrie C is already on the ground in Indonesia and ready to help. Although much of the fault line lies beneath the water, it does break the surface in places, forming a chain of volcanic islands. C hires a helicopter and flies north along these islands, looking for signs of recent seismic upheaval. As he approaches the island of Semilu, he sees something that catches his eye. A ghostly ribbon runs along one side of the island, a reef that clearly seems out of place. It's incredible evidence.
I realized this island has come up out of the water and the entire reef is now exposed and dead.
The tilted island marks the beginning of the tear in the Earth's crust.
We knew we had nailed down the south end of the source of the earthquake and the tsunami.
If C surveys the other islands dotted along the megathrust, he could gather enough evidence to plot the true length of the rupture. But at this critical moment, the investigation receives a body blow. C is denied access to the northern islands because of political turmoil there. he can go no further. If the length of the rupture remains a mystery, investigators will never uncover the truth behind the most notorious mega tsunami in history. Stay tuned for more seconds from disaster. Investigators are on the verge of discovering why the 2004 tsunami was so deadly over such a wide area. Geologist Kerry C. has located the start of the earthquake rupture. Now he desperately needs to prove how far north it stretches. But political turmoil in the region has made a helicopter survey impossible. Then, a team member comes up with a brilliant solution. If they can spot such dramatic physical evidence from the air, then why not from space? They track down a satellite image of an island prior to the earthquake, then juxtapose it with an image taken afterwards. Comparing these images provides a breakthrough. The outline of the island has altered as a result of being tilted in the water. The team analyzes images of other islands along the megathrust, calculating the amount of movement on the seabed. And this analysis provides concrete proof. The rupture is a staggering 1,000 miles long, the biggest ever recorded. A rupture of this length should be more than enough to account for the destruction witnessed as far away as Sri Lanka. Tsunami expert Kostas Sinalakis returns to the wave simulation program and feeds in the precious new data. This time, the simulation predicts a tsunami that mimics almost exactly the distribution of real attacks. In this scenario, a California-sized chunk of Earth shifts nearly 70 feet, creating a complex pattern of waves.
As it moves up, the piece of seafloor of ocean bottom has its own peaks and valleys, and that creates the initial surface of the wave.
This unique pattern sets in motion a sequence of undulations that scientists call a wave train. In the deep ocean, the wave crests are less than 2 feet tall, but the wave train travels at incredible speed, 600 miles an hour, as fast as an airliner. Beneath the surface, a deadly column of water passes through the full depth of the ocean. As each wave enters shallow water, it slows down to about 25 miles an hour. As the back of the wave catches up with the front, the wave rises, and the tsunami takes shape. The wave train simulation correctly predicts where and when the real tsunami approached all the affected coastlines. Proof that the team has discovered the true source of the tsunami. But the scientists now face an even bigger challenge. They must somehow explain the bizarre and terrifying events experienced by the victims. In Thailand, the water retreats from the shorelines about 10 minutes before the first waves hit. But 1,200 miles away in Sri Lanka, a mountainous wave simply slams onto the coastline with no warning. And then there's Banda Aceh. The city is reduced to rubble for miles inland. It's the most extensive tsunami damage ever recorded. Understanding what caused it is vitally important. not just for this part of Asia, but for low-lying coastal regions all over the world.
Why is the wave so destructive so far inland? It's something unfathomable.
Sinalakis and his team arrive in Banda Aceh, and they get straight to work surveying the damage to the city.
Tsunami investigations are forensic investigations. We try to reconstruct what has happened, and we pick up clues very much like detectives on a crime scene.
The team needs to measure two key dimensions. The first is the maximum height above sea level that the water reached, known as the run-up. The second is called the inundation. It's the distance that the water travels inland. The position of debris and watermarks reveal a run-up of 33 feet above normal sea level near the beach, and a 10-foot run-up in the center of town. The inundation is truly amazing. The water sweeps an astonishing 2.5 miles inland. Huge volumes of water pass through the city, but it's the speed of this water that does the real damage.
One cubic meter of water weighs 1 ton. So for every cubic meter of water that comes in, and we're talking about now hundreds of thousands of cubic meters, it's like having a car that's coming in at high speed and it's hitting you.
So, the first step in solving this riddle is to calculate the water speeds across the city. If Sinalakis can establish the time the water took to travel between known locations, a simple calculation will give him the velocity. But getting this information isn't easy. The first place to look would normally be eyewitness accounts of the event. But sadly, in this case, most of the witnesses are dead. Of those that have survived, many are too traumatized to help.
It's very difficult to get very, very precise information because a lot of people are in a complete state of shock. They've lost, some of them, all members of their families.
But eyewitnesses aren't the only source of information in Banda Aceh. The streets themselves have a story to tell. All across the city, they're coated with marine sediment, sand and mud that waves picked up offshore and carried inland. Sinalakis knows that the depth of this sediment is directly related to the water's speed at a given place.
If the tsunami comes in, very, very slow, we expect to see, more sediment close to shore. If it comes very, very fast, we expect to see thicker sediment layers further inland.
So this dirt will be his speedometer. The team carefully measures the layers of sediment deposited in key locations. Their painstaking analysis reveals that the water flowed at up to 20 miles an hour across most of the city.
I would have expected the wave to penetrate inland, but I had never expected this kind of speeds, 20 miles per hour, 3 meters flow depth, 2 miles inland. This just didn't make sense.
He's at a loss to explain how such huge volumes of water could travel so fast, so far inland. And then, another vital piece of evidence. Sinalakis discovers a video which shows the water arriving in the city center.
The piece of video is a turning point for us.
Captured on tape, the wave seems to defy physics. As it hits these streets 2.5 miles inland, instead of slowing down, the wave accelerates. If he weren't witnessing it with his own eyes, he'd consider this impossible. Sinulakis scans the video for clues. Rewinding the action, he focuses on the minor flooding that precedes the main torrent.
The first wave was very, very slow. And you could walk away from it.
Then he makes an observation that will radically transform the science of tsunamis. He notices that this first wave of shallow water is actually paving the way for disaster by acting as a low-friction surface for later waves to travel on.
The second wave is moving on this very, very thin layer of the first wave. So it's able to propagate much faster.
The wet surface of the first waves allows the second wave to power through the streets without slowing down.
Suddenly the second wave accelerates and goes at a speed of 30 to 40 kilometers per hour.
And with tons of shattered debris mixed in, it's a deadly flow.
It's like being thrown in a concrete mixer with nails and hammers and screwdrivers. This is unfortunately how people die. They had no chance.
It's a grim but valuable lesson. If the tsunami hits the city, neither outrunning the water nor hiding in a back street will help. The only escape is to get to a solid structure and go up as high as possible.
The difference of life and death in Aceh, in some cases, it was a difference of a few inches.
Sinulakis is close to solving the tsunami mystery. But first, he still needs to explain a bizarre phenomenon. Unbelievably large waves were reported down in Lochna. Sinulakis asks veteran tsunami scientist George Plafker to investigate. Plafker meets with Samsul Kamal, the local street trader who climbed a hill to escape the water. Plafker's team measures the run-up at Samsul's hilltop refuge. They discover that the water reached 115 feet above sea level. That's higher than an 8-story building.
That's by far the largest tsunami associated with any earthquake in history.
But there's more to Samsul's story. He's sure that the waves arrived about 20 minutes after the quake began. Plafker is stunned. He knows that waves from the megathrust over 100 miles offshore would take at least half an hour to reach Lochna. For the tsunami to arrive within 20 minutes, there must be something to account for the time difference. Something capable of causing the massive waves to arrive much earlier than was thought possible. It's a huge setback.
This is nothing less than throwing us back to the drawing board.
This anomaly strikes right at the heart of the investigation. By resolving it, the team will rewrite the rules of tsunami prediction and reveal just how vulnerable people who live near offshore faults really are. Investigator George Plafker has discovered that monstrous waves arrive on Sumatra's coast too early to have come from the source of the main tsunami. The investigation is in crisis. For Plafker to solve a problem this complex, he's got to go back to the basics. He knows the waves arrive about 20 minutes after the quake began, and he knows how fast the waves could travel through the waters immediately offshore. So working backwards, he calculates how far away the waves must have started their journey.
It turns out that the wave could have traveled a maximum of about 100 kilometers.
Plafker consults a detailed geological map of the seafloor. There, 68 miles offshore, he sees strange features that catch his attention. Distinctive folds in the seabed. Could these be the answer? Splay faults are often found near large earthquake zones. They occur where enormous forces find a weakness in the highly stressed crust. Then, fractures break through to the surface, many miles from the main fault. These faults can cause a long, narrow section of the seafloor to pop up in a matter of seconds. And this can produce a distinctive short burst of high waves, just like those that flattened lava. And when a computer simulation incorporates Plafker's splay fault, the results are nothing short of spectacular.
Lo and behold, it more or less doubled the height of the waves at Lucknow, and it shortened the time, of course, of arrival.
With a pop-up fault located close to shore, the simulated waves closely match the awesome descriptions of eyewitnesses. Although it will require further research to prove, Plafker's explanation is a breakthrough. But there's one final question raised by this catastrophe, perhaps the most important of all. Can anything be done to alert people to the danger of an approaching tsunami? Sophisticated warning systems are in place around the world. They're capable of detecting a tsunami as it passes through the open ocean. But even these high-tech systems can't provide a perfect solution. For 60% of the victims of the Asian tsunami, no alert would have helped. Many were simply too close to the source of the waves for a warning to have had any effect. There was simply not enough time to react. But in the aftermath of the disaster, investigators think they've discovered an unmistakable tsunami warning sign. In many places, the ocean recedes before the waves hit, leading some to believe that an exposed seabed could be a natural, universal tsunami alert. Not only does Sinolakis disagree with this theory, he thinks it may be a potentially lethal myth. He's long held a theory about what could create these strange recessions. As the fault ruptures, the easternmost section subsides, pulling a trough of water down with it, a negative wave. As this approaches the shore, it draws the water away before the first crest arrives.
On this side, where the seafloor subsides, what you see first is the shoreline retreating.
All the waves traveling east lead with this trough, but to the west, it's a different story.
On the other side, where you have the seafloor uplifting, what you see moving west is a leading elevation wave, or, the crest comes first.
Until now, this has just been a theory. But finally, Sinolakis has evidence that confirms his hunch. Locations to the west saw no recessions, no natural warnings, just massive walls of water slamming onto shore. And this important finding doesn't just debunk a myth. Ultimately, it could save lives. The truth is, there's no single foolproof indicator of an imminent tsunami. Finally, we can reveal the critical chain of events that plunged the people of the Indian Ocean into a primordial fight for survival. to 2004, scientists identify the southern section of a fault line near Sumatra as being at risk for a massive earthquake. December 26, 2004, 1 minute from disaster. A section of fault further north than expected begins to break apart, and a weakness in the crust creates a shortcut to the surface. 8 a.m. A narrow section of ocean floor, about 60 miles long, pops up more than 30 feet. 3 giant waves approach shore. Meanwhile, the tectonic plates themselves spring apart, displacing billions of tons of water. The earthquake's energy is transferred into the shifting water columns. It's equivalent to more than 30,000 Hiroshima bombs. On land, initial flooding creates a low-friction surface for later waves to glide over. This creates huge water velocities and turns debris into deadly projectiles. The human cost? Incalculable. The unexpected location of the 2004 quake means that every undersea fault must now be considered a tsunami threat. Kostas Sinalakis is painfully aware that his home on the seismically active West Coast is inherently vulnerable. But his experience with the Asian tsunami has only increased his resolve to plan for that day.
Whenever we see a tsunami on the west coast of the United States, we're going to be prepared, and hopefully we're not going to have any human victims.
Oh my God, look at the waves coming! Clear out!
As for Ken Moore, his experience in Thailand was a wake-up call.
I don't take life for granted anymore. I realize that it can be all over in a second. And boy, I kiss my kids every day before I go to work.